Parallel and perpendicular lines. First of all, the definition for parallel lines. Parallel lines are lines that never touch or intersect. Perpendicular lines are lines that intersect at a 90-degree angle or a right angle. The notation for parallel lines, just a couple dashes. And the notation for perpendicular line kind of looks like an upside down T. Anytime you see the words parallel or perpendicular, or working with parallel and perpendicular lines, those are key words that you're pretty much are going to be using the slope, or working with the slope for those two lines. So what you need to know about the slope of parallel lines is that they're the same. Parallel lines have the same slope, but you also have to make sure they have different y-intercepts. Because if they had the same y-intercept and the same slope, they would be the same line, therefore they would not be parallel. So take a quick check, make sure the slopes are the same, and that the y-intercepts are different. Perpendicular lines, the slopes are opposite reciprocals. For instance, if one line has a slope of 1/3, in order for a line to be perpendicular for it, first of all it has to be the opposite, which would make it negative, and the reciprocal of 1/3 would be 3/1, or 3. Opposite reciprocals, therefore perpendicular lines. Another example, if one line had a slope of -7/2, in order for a line to be perpendicular to it, its slope must be the opposite reciprocal. So the opposite of a negative number is positive, and the reciprocal of 7/2 is 2/7. So example 1, are these two equations, linear equations, parallel, perpendicular, and maybe neither one? So like I said, as soon as you see those words parallel or perpendicular, you want to think of the slope. So that's what we need to begin by finding. Now example 1, both these equations are in standard form. So we don't know what the slope is, so what we're going to do is rewrite each one in slope-intercept form, where then we'll be able to easily determine the slope. The first one, x plus y is equal to 6. Just subtract x from both sides. Y is equal to negative x plus 6. So its slope is -1. The next example, subtract x from both sides. Negative y is equal to negative x minus 3. And then divide everything by -1, so y is equal to a positive x plus 3. Its slope is equal to a positive 1. So they're certainly not the same slope, so they're not parallel. They're opposite reciprocals. So these are perpendicular lines. Example 2, same thing. Determine if these lines are parallel, perpendicular, or neither one. So since they're both in standard form, we want to begin by putting them in the slope-intercept form. The first one, subtract x from both sides. And divide everything by 3, so y is equal to -1/3 x minus 4/3. So its slope is equal to a -1/3. The second equation, subtract 3x from both sides, so 9y is equal to -3x plus 8. Divide by 9 and simplify, y is equal to -1/3 x plus 8/9. So its slope, once again, is -1/3. So obviously they have the same slope. Take a quick check, make sure their y-intercepts are different, just verifying that they are actually different lines. And they are different, so therefore these two lines would be parallel. They would never touch or intersect. And example 3. Write each equation in slope-intercept form. First one, subtract 30x from both sides. Divide both sides by 10, so y is equal to -3x plus 17/10. So its slope is equal to -3. Second equation, subtract 12x from both sides. Divide by -4, so y is equal to 3x minus 9/4. Its slope is equal to +3. So they're opposites, but they're not opposite reciprocals. They're not the same, so they're not parallel. They're not opposite reciprocals. They're not perpendicular, so they're neither one. That means these two lines will intersect since they're not parallel, but they will not intersect at a 90-degree or a right angle.